Oh, it's
But
crazy.
Hello, hello.
Oh yeah, sure. We will stand here, right? Otherwise, stand in front of this. That should also work.
Yep. I just put it back on.
Just here in the corner.
Do you have a Wi-Fi we can use for the presentation?
Yes,
Sorry for
it's
the
called Brevo guest, BRV guest, and then you pop up. You need
Okay. But do I need a
you need somebody to
Yeah.
somebody from Brevo.
Okay.
Stand.
What do you need?
Connect to Brevo.
You need to go to Brevo guest. Eh ben, tu peux mettre le lien IOTP. Point ITIC. Non, non, point, point ITIC. SOHN. Oui, brevo.com.
Tu reçois un mail, tu dois cliquer pour approuver le. Une fois tu cliques, on peut cliquer son téléphone. Ah, c'est non, lui. Et après, c'est bon. Ça devrait être là.
C'est bon.
Non, ça.
Pourtant, thanks for approving, Stanislas. C'est bon.
Non, start. Which is my laptop. Why do I have to?
Okay. So we are recording the session, by the way, for everyone to know. Great. Cool. Very warm welcome. Really, really cool. It's our very first event in Paris. What we're doing, we just did that once in Munich. I'm Adam from ZenML, co-founder of Hamza. And tonight we want to walk you through the journey from MLOps to whatever will come after. And this is why we have 4 different talks. First one is Brevo. Thanks for hosting. By the way, it's really amazing. We're working together for now more.
Sorry.
Okay. Test. Works? Okay, that's great. I'm recorded. Good. Yes, thank you for Brevo for hosting this for us today. It's really, really great pleasure. So we are working together for 1.5 years now. And
Sorry.
Just switch off the sound.
It's weird. Okay.
Just
As we wait, maybe like just a quick question. How many of you have agents in production already? Agents, just agents. Agentic use cases. And how many of you are, let's say, AI engineers? Almost half of people. And who is a data scientist or more doing classical ML?
cool mix.
Yeah, so about like 10% out there. Okay.
That's fast. No, works good. Great.
Cool. Then we
Have fun. Looking forward to mingle afterwards.
Good evening, everybody. Sorry for that. Did I start the recording already again? What?
recording.
I'm not sure. Sorry, it's just why it says unavailable.
No. We have, this meeting note taker is our recorder. Participating in the
Okay.
meeting.
That's fine. So we should have it. You can start, Leonardo.
All right.
Thanks for checking.
So tonight I'm going to talk to you about our MLOps journey at Brevo. Basically, I'm going to set the ground for the next talks. The idea is to share with you in around 10 minutes how we started the journey and what's coming up for us. So I divided this talk into 4 points. First, an introduction with some context, and then to show you a use case based on phishing detection. Then what's coming up for us in terms of infrastructure and MLOps, and we're going to end with a Q&A session. I want to give you a disclaimer, and it is that although this talk, my talk, is focused on pure MLOps, well, there are some key concepts, of course, that could be in parallel with LLMOps world, and then agentic workflows, so like versioning, where we talk about performance. We want to talk about performance of models, and then in the LLM world, then we want to talk about performance of one LLM against another provider, or one prompt version versus another prompt version, what suits best for a specific task. And when it comes to training also, we talk about in classical machine learning about training a model or fine-tuning a model, but in LLMs also we want to, or sometimes we need to fine-tune an LLM to make it like very specific for a domain or just to make a specific task. But in both cases, we always care a lot about performance, reliability, stability of the infrastructure. So with that in mind, first thing is to talk about what do we do at Brevo. Well, we are a marketing platform, customer relation management. Basically, our goal is to engage our clients' audiences to help them to grow their business. So with that in mind, why MLOps is important to us? Because basically, when dealing with emails, SMS, etc., we have many problems that we can encounter, and in those cases, we could face batch processing problems, or maybe we need to rely on live predictions in case, for instance, of fraud, where we want to stop the fraud as soon as we can. So when we started this MLOps journey, we had a legacy projects that were spread in different platforms or tools. So we had BigQuery ML models that are very useful when you master SQL, but you don't want to get your hands dirty into infrastructure or everything related to MLOps. So, but of course there are some limitations. But also we had some other models in Google Cloud Functions that were also simple models that were very hard to maintain and maybe didn't perform very well and were very limited in terms of many things like GPU usage in case we need it, or just the handling the volume. But also, again, we found isolated notebooks that we wanted to basically gather all these different models, all these environments in just one thing. And to show you the use case that in particular I face, so I wanted to present the phishing detection model that we used, that we created here at Brevo. Basically, the problem with phishing detection is that this degrades a lot the reputation of Brevo, not only with our clients, but also with providers, basically the reputation of our ISPs at the core of our business. And the idea is to stop these emails, to stop them the sooner the better. This is what a phishing email will look like, something like asking for personal information, payment, etc. Sometimes it's very easy to spot, like in here, okay, best wishes, Microsoft@gmail.com. Well, it sounds very easy to spot, but sometimes it's more challenging. So from a data science point of view, it's very interesting to tackle such problems. But also we face some technical challenges, like the volume. We send hundreds of millions of emails per day, and also these phishing attacks can occur in basically any language. So to solve this problem, this is the stack we used. Basically, our cloud provider is Google Cloud, and we found out that ZenML was the best tool that suited our needs. So our stack looks like this currently. So we create a data set with BigQuery, and then use Artifact registry to store the models, and then Cloud Build to create the images, to store them in GCS, and then Vertex AI will serve us as the orchestrator and also for model serving. And this is basically what a training pipeline would look like. So just a set of steps that are concatenated. But the thing is here that at some point we want to have monitoring and alerting. For instance, at the very end of the pipeline, we've got a few steps that will help us to log a version of datasets, a version of the parameters that were used to train the model, and also to track the performance of the model with respect to the previous version. So in case there is a problem with the retraining of the phishing model, and then we will be notified through Slack, and then we will do an action, like, for example, go definitely to production, maybe do an A/B test if you're not sure. But also in terms of monitoring, we use Metabase. The idea here is to not only share this performance with technical colleagues, but also with business stakeholders. For instance, in phishing detection, one important OKR is how many fraud email we send per month, for instance. And this is something that we can share with the stakeholders. They don't care about precision, how many false positive, how many true negative, etc. They care about how many emails we send that were in the end like detected as fraud. So we use Metabase for this, but also to, of course, some technical monitoring in our case. Normally in our pipelines, we always save a model after the training. We have a step to save the model because we have another pipeline that will just take this model version and will deploy it, as I said before, through a model serving Google Vertex AI. This interface is a bit different than the previous one because this is an ZenML interface for the pipeline executions or DAX. And the cool thing is that we can always have different version of the model. So for instance, we can start with version 1, then second, if there is a minor change, then 2.1, etc. And for each version, we can always attach interesting information or metadata, like the version of the data set that was used. This could be also done, for instance, when we fine-tune, we already have fine-tuned, for instance, an LLM for a specific task, and you can always have for each version for instance, what was the data set that was used, or even the kind of fine tuning that you perform. To do the releases, we use a very nice and very cool tool, Release Please. Basically, this helps us to the model serving and the ZenML upgrades. Each time we need to upgrade the version, it was a very painful point for us. So with just conventional commits and PRs that were automatically generating new PRs on a Release Please, we were able to make deployments smoothly. And basically, this also helps us to, in case of a problem comes up, then we can roll back very easily, just changing a tag just with one commit instead of retraining or maybe just going on manual manipulations. And for what's coming up for us, we are currently in a migration. We decided to get out of Google for now and then go to OVH. And the cool thing here is that ZenML has been very helpful because as data scientists, for us, it's just a matter of switching stacks. So currently, when we want to deploy a model or run a pipeline, we just select the stack and it goes through Google Cloud and Vertex and Yen. But right now, we'll just have to switch a stack, and this is an example. I previously showed to you what our current stack looks like, but this is like an intermediate stack that we use for large pipelines. So in this case, we're replacing, for instance, Vertex AI as the orchestrator, and we are using a Kubernetes native component to orchestrate the pipelines. So little by little, we're gonna switch all the components. So it's just a matter of switching stacks, and we'll just migrate everything very smoothly. If you have any question, please. Thank you very much.
Very obvious question: why migration from Google Cloud to OVH Cloud? Like, what was the decision making? And then any challenges in the MLOps pipeline?
Any migration is always really like painful. But basically, well, Brevo is a French company, and we care a lot about like we're proud of this culture. So OVH being a French provider will make sense to our identity. But yeah, this requires a lot of work, mainly from the platform team. But this is one of the reasons. Anybody else? Well, I can do like the Vertex AI. Yeah.
You mentioned Vertex AI for the stack, and with this migration, what would be the solution then?
Yeah, good question. Actually, the stack that I showed you was for batch pipelines, which don't require for any model serving. So for the model serving, we're going to use Seldom, and we're going to deploy as a component or the new stack, but this is not something that we're doing. We're just in the process.
Thanks. Yeah, I want to ask, do you usually do tests before release the model in production? And if so, what kind of tests? Like only on performance or also on, I don't know, latence, things like that?
Yeah, well, when it comes to tests, we definitely test the performance. So in this case, for phishing, it's a bit tricky because the thing is, phishing evolves with time. So if you want to fix a data set and compare two models, it makes sense, but then it doesn't make sense that much because then you have to be up to date. So in this case, we make the test set, data set evolve also, which I know it's not strictly how like very comparable, but this is the the approach we decided, because this is something that it changes and changes a lot. And then when it comes to all the kind of unit tests, depending on the model itself, actually depends a little bit of what we have. Some unit tests that are for like another APIs, but for this one, just like we just make sure that the format is always good when we get the request, and that the performance is okay. And if there is something that we in the request, we always like make sure that we provide the right message. All right. So thank you very much. If there is no more questions, I will give the mic to Hamza.
Yeah, thank you. Amazing. Just give me 1 second to set up. Should I just share my screen again?
Yeah, share your screen and unmute yourself.
That should work, right? Okay, no echo. Thanks. Cool. So thank you, Leonardo, for laying the groundwork for MLOps. And the idea, of course, of the whole meetup was how MLOps is evolving as agentic workflows become more and more popular and somehow get into production. I mean, let's see. So today, what I want to talk about is what sort of a reflection of how I saw personally workflows evolve with machine learning operations and how they're going towards agents. And then we're going to have 2 talks who are actually doing agents in production, so we can see how that differs. So I'll try to keep it short and sweet. Oops. Yeah, so the idea is lessons from the past. Let's not reinvent the MLOps. Oh, I'm standing in front of you. The MLOps loop with agents. The poll I did at the beginning is quite reflective of numbers that we see in reports. So obviously nobody knows the real number. This is just something I pulled out of some resource. But I think it's true that most AI projects or agentic projects actually are not in production today. Very few use cases are actually producing business value, especially in the enterprise. Of course, we all know some use cases like Cursor and the coding agents or some vertical agents like Harvey, for example, in the legal space that works. But if you look and talk to the customers we have, for example, which are big enterprises or even smaller companies, they're still struggling to get things into production. And that's just a fact. I want to understand why. So the whole journey of successful AI adoption for companies historically has really been predicated on a few revolutions that happened, from data foundations where we all moved to the cloud, to some advanced analytics where we did business analysis, which led to a lot more problems, which led to MLOps. And now we're doing LLMOps with RAG, and now it's going towards AgentOps. So these layers are all building on top of each other. I don't think that I see them as distinct entities. I don't think that there's anything where you can just separate them and say that, oh, we have to do LLMOps completely from the beginning. I see it more as an evolution of what we learned with, for example, the pipeline that we saw with Leonardo, which was going from training to deployment, to having more of a reasoning model at the beginning, and then still having a workflow that powers some business value. I should introduce myself first, right? I forgot. I'm so sorry. My name is Hamza. I'm the co-founder of ZenML. Adam and I have been doing this for 4 years. So our team is about 14 people now, based in Germany. And we came because we were doing a lot of machine learning before in another company we founded, and took all of those MLOps ideas and open sourced them. And then ChatGPT happened. So the key MLOps foundations that I saw in that time was, of course, ML engineers became a thing, MLOps teams, MLOps platform teams became a thing. Different experiment trackers, MLflow, I guess everybody used. But essentially the cloud platforms dominated, and there was a few players that emerged. Our approach at ZenML was really to abstract the entire pipeline, but that's a different story. But what really drove MLOps foundations forward was really the groundwork that we did in making these models reliable with cross-functional ML teams, self-serve ML platforms, model risk management, governance, and all those boring things. But really, that was the foundation of that. And it had tremendous benefits. So we actually, this is based on a real, like many real use cases we've seen where we saw people share the workflows that they're doing across business units and countries and really have this sort of AI factory effect where you could leverage the learnings that you did in machine learning in one part of your company and apply it to others. And this is because you standardized it, you ran it through a central governance framework, and you had some security and some sort of a platform that gave people the ability to do that. And then, as I said, first this. So traditional ML basically, so as you all know, traditional ML also started as scripts and notebooks. I think agents basically start like this as well, to be honest. Somebody writing a script where they're calling LLMs. But before, like back in the day, we used to see reading CSV from some random data file somewhere, doing some sort of compression, doing some NumPy magic or pandas, doing a classified.fit. That still exists today, of course. But really, the whole goal was that this was a cluster. It didn't work. So it was really hard to get this into production because we didn't know where the data was stored. We didn't know what the lineage was. We didn't know how to resume from a certain point of failure if the NumPy magic failed. We didn't know how to scale out if we wanted to do this AI factory thing. And of course, we had to version data and artifacts. So not just the code that was shipped, but also the data. And essentially, the core motivation of MLOps was to go from these sorts of manual processes to automated testable workflows, where we broke these things into individual steps, and we put them into DAGs, directed acyclic graphs. And each of these steps were testable and could scale out individually and could be deployed on any like cloud provider, OVH, GCP, Kubernetes, or whatever. So this whole movement, how we went from the left side to the right side, was what we basically achieved in MLOps. And most companies today, I think, have an MLOps function that allows them to do that. Yeah, and as I said, ChatGPT happened and everybody forgot, I think, that this was important. But I think, like, really, it's, I guess I'm a bit unfair on best practices because this agentic loop phenomena is quite new. So for those of you who are engineers, who are like half of you, you might have seen this. So like you can see that if you measure how long or how complex of a task an LLM can do, it's actually doubling every 7 months. So this is sort of the new Moore's law, which is driving a lot of growth and hype. And you can see this actually kept going. So I kept an eye out on Sonnet 4.0 and all the latest ChatGPT models and even the recent DeepSeek model. And this graph is actually accelerating. So while you can, I think with 3.7, they put some experts who could do a task in an hour, and like Sonnet could do that with no problem. I think if we go into this trajectory, the promise is that we could essentially do 1 month of work with these agents by 2027. So that's the rate of growth that we're experiencing. And most of this is driven by test time compute and reasoning and these agentic loops. But maybe we should, like before we go into the agentic loop, I think we should start with LLMs and how they're adopted and how people are mostly using them on the ground. So I think most of you probably began with a prompt, LLM processing, and a final output. And I think this is fine. I mean, it does get you some results, especially if the LLM has some sort of reasoning loop inside. But what we quickly started realizing is that, oh, you could do a lot more before to get some context into the LLM to increase the quality of that output. And then we also started to think that, oh, if we just kept asking the LLM to reflect on itself, you could look back, do some action with some tools using let's say, the new MCP standard, and the result just keeps getting better. So it doesn't get lost, which is sort of counterintuitive if you think about it. And now what people have started to do is they've started to put more steps in and around that reflection loop. And this is, I think, what most people call agents. But for me, when I look at that, I start to think that this looks a lot like what we saw before in workflows. So for me, this looks like you're doing a set of predefined actions. And you're doing these using, let's say, a reasoning layer of a model. And actually, workflows are great. I mean, we've been using them for years in classical ML. They allow you to separate environment from code. So the analyzer step could run in a different environment, which has more access, for example. It allows you to version these pipelines, compose them, track the metrics, evaluate them. You can restart from the middle if you mess up. And you can test these things and reproduce them and have provenance, lineage, and all those security things. So that's that MLOps loop that we did. Those were the reasons we did that. So workflows are really cool. And my take, and this is really why I just wanted to get this out, I guess it's not much of a spicy take for those of you who've actually done this, is that in my opinion, today production use cases work way better with deterministic LLM-powered workflows than with autonomous reasoning systems. There are very few use cases I can think of, apart from, let's say, cursor or coding or something, where you can let this agent go up on its own and do whatever it wants. It's not smart enough yet, even though the power is there. And there's lots of other reasons why you would want to have a workflow in the first place. Like think of, I mean, this is the classical building effective agents from Anthropic. For me, workflows are essentially agents with less agency. So the more agency you give this, the more you let it decide what the next thing it should do, the more entropy enters into the system. And for any sort of enterprise or medium scale business, that probably doesn't work for most of your use cases. So what we really want to do is we want to break these things down and control where the control flow goes. And that starts looking a bit more like workflows. So for me, if we start thinking about agentic applications as loops that are predefined in code paths, you can actually get all of the benefits that we had from MLOps, which is all the things, I mean, there's a few new things, right? You can version prompts as artifacts, which I still believe. You can track token metrics. You can deploy on any infrastructure if you wanted. You can maintain state and memory, so you can start these things from the middle if they fail, which they tend to do. And yeah, you have all this reproducibility, provenance, lineage that we had in MLOps. So why don't we just learn from what we did before? And what I also see as a pattern is, if you start thinking of these things as workflows, back in the day, we used to put machine learning models into the backend and used to call them. So we couple the sort of the machine learning logic with the business logic of the API. Alongside the infrastructure we deploy them. But if you start thinking of these as independent services, you can separate the agentic development lifecycle, eval it separately, deploy it on its own infrastructure because it needs a special siloed infrastructure, and really have that as a separate job, almost like an AI engineer's job, and have the fast API or the business logic separate, which is just running and just calling that. So I think that we will see more of that as we go along. How much time do I have left? Like not at all? Okay. So I just wanted to show you a quick demo of this idea. So let me see if I can do this. So I wanted to, before this call, I was wondering, for some reason, is wearing sandals with white socks in Paris actually a crime or just social suicide? For some reason, because I like to do that. And I don't know much about Paris, I just came in. So it's actually researching, like Claude research we just launched. It's still researching. It's 12 minutes in. But this is going better than I thought. Okay, it has it. So it researched and it did a lot of cool things. So I mean, of course, this is amazing. This could be used in a lot more serious context than I did. But you can see what the conclusion is. The sandal with white socks controversy represents more myth than reality. I have no idea this was actually a thing before I typed it in. But imagine if, I mean, in a work context, I mean, you might have queries that are way more serious than this, right? But the thing that happened was I typed in this query, it ran off in its own, it did whatever it did, and it came back and gave me this result. And I have no control over this process. So what I did was I really didn't like this because we were using like deep research a lot for different research that we were doing at ZenML. So we actually built our own deep research pipeline. And you can see this is how it looks like. We have to really work on this view, by the way. Let's see. So, I mean, this gave us a lot more control over how this looks like. So we could decompose the query that came in into 10 different like sub questions. We could reflect. We could ask different questions. We could have different parts of the report that we wanted to give to our sales team or marketing team, whatever. And we have a lot more control over this. So, for example, I can see my prompts. I can see I have 48 versions of this prompt. I can see what the prompt is. I have midterm reports. So if I wanted to see how much it cost, has the perception of wearing sandals with white socks evolved over time? Well, this is not such an interesting one, but you can see maybe here. Yeah, so it's doing a lot of research on sub questions, and then it's going and it's reflecting. So if you go into the reflection step, it's reflecting a little bit more, and it's producing an updated analysis report. Then it's calling out MCP for EXA search because it's using EXA. Again, we have all the prompts version, and I can see what's happening. And then at the end of the day, it produces a report, which I can then forward to whatever internal team wants to know why wearing sandals with white socks is a crime or not. And now this report is way more catered to my needs and to my use case. So I can really go back. I can start from the middle if I wanted. I have a lot more control over the cost of it. I can set budgets. I mean, here I also used LangFuse and ZenML to see how much it costs. So it took 4 minutes, 68,000 tokens. It tells me what, yeah, in this case, I use Gemini. And so, yeah, so there's a lot of telemetry and lots of observability I can put when I start controlling these workflows. So, yeah, I mean, that's my take and a small demo. Let's go back to this. What's the next slide? Yeah, so that's the conclusion. I mean, essentially what I want to say is let's not reinvent the wheel. We can learn a lot from MLOps already. The workflow abstraction worked in MLOps. We expect it to work better with agents. Try to think about agentic apps as workflows first. Start simple before you go full autonomous. Never go full autonomous. And yeah, let me know what you think. I mean, this is an idea I've been thinking about for the last 6 months, but I haven't really, yeah, I'm sure I'm wrong about some things. So, we would love to have the chance to challenge my opinions. Thank you. Any questions? Yes.
So I also think this workflow are great. First, that's also our approach. But I was wondering in my case, like, do you see the parallel when someone say like you can fine tune a model, but like after 6 months, like a new foundational model will get released, and then your work basically became useless, right? So do you have any tips to like build workflows, but being able then to fully like leverage new foundational model, right?
Yeah.
Because sometimes you can build a workflow that's limiting the LLM, but that's not what you want to do, right? So do you have any, like, did you talk about this? Do you have any tips?
Yeah, I mean, this is something that's one of the classic problems, right? Like you don't have sort of the models pull the rug out under your feet when they get released. But I think that sort of speaks to why you want workflows in the first place, because essentially it's just dropping in another config parameter, running it on your eval set and seeing how it performs. So if you have the ability to go back and even run it through real data, I guess that mitigates it. But essentially that problem is really solved by how you decompose your workflow. Because I think fundamentally what we need to learn, I think, together is how do you get steps like what should the step be? Like why should in the deep research, why should there be a decompose into sub questions? Why should there be a reflection step? Why should there be a cross viewpoint step? Those things you can only learn from experimentation. And if you scope one sub task into a manageable enough thing, then you should feel less of like jitter when these models update. And maybe some models might perform better at certain steps than other models, but this you just need to keep experimenting and running and have an engine where you iterate.
This is kind of related, and reflection. When you talk about deterministic workflow, I think it's related to kind of problem that nature of the problem push us human to deterministic solve it. And in this domain, I would say AI have a little leverage. In this, I think it's interesting where we cannot be deterministic because we don't know how. And intuitively, I don't have any successful experience. I did, but I haven't yet resolved. But I felt this is where we can have real advantage, where by nature of the problem, we don't know how to do it. Then it's not deterministic by nature. This is where we need to more focus.
I mean, look, if you ask me about the vision of a multi-agent, autonomous, collaborative ecosystem powered by something like MCP, I am with you. But the reality is that if you talk to people, if you give agents or LLMs more than 3 tools, they get confused. If it goes past 4 steps, it can get confused. Even the deep research stuff you see with Claude is very guided, actually. It's not, if you look under the hood, they have lots of guardrails. If you read their system prompt, you can also see it. So I'm with you. I just think that we're not there yet, that we can let this go. I mean, I imagine it's going to be a gradual process. So, I mean, right now we have I showed you a completely deterministic workflow, but you can imagine adding a bit more agency into these mini agents, steps that do a limited amount of work. Then they can go off and have their own mini loops and come back. But the whole process can still be a bit more deterministic, and it can have some checks and balances. And eventually, I think we'll get to the reality of full autonomy. I just don't think we're there yet. So, yeah.
Because a reflection, I think the path that I'm trying to experience is not less trying to control one. It's more like when you see the human in organization. When the guideline, how the organization works, not every individual. And the system is stable. Not even every, we could have confusing agent if collectively they can control each other. This is the person trying to have a result, not yet successful. But
it's a cool idea, though. Any more questions? Yes, maybe a last one.
It's more of a meta question, but like, you really see a lot of people moving from like classical ML, something like, I don't know, binary classifier or sentiment analysis or whatsoever, moving to like agentic. I don't think a lot of people have use cases that like require moving to agentic, right? That's because you're saying like there's this trend going and everything, but
why do you think so?
I mean, I remember a couple of years ago, I was looking for a job in Paris, like for people doing deep learning in production, and there's no one.
A couple of years is like 9 years.
Yeah, exactly. But like, so like a couple of years ago, no one was doing deep learning. So I guess now today, like, who's doing like agentic?
Of people do deep learning. Deep learning and agentic, it's not the same.
For sure, but like I'm saying, already deep learning. So like, sentiment analysis, you don't need like an LLM, right? Don't even need it. So like, I'm just curious, like, did you really see a move like from classical ML to a lot of people moving to agentic?
Yeah, I saw a big move.
Yeah, for real.
And we have 2 speakers who will talk about this.
Yeah, I mean.
So it was probably 10 to 100 times more what I felt when we saw. I mean, obviously, machine learning was the in thing for a while as well before, but like this thing is a bit different because you don't even need the ML capabilities, right? You could use LLMs, so software engineers are doing it, front-end engineers are doing it, data analysts are doing it. So sort of it's a bit more surface area, and I would say the floor is lowered. I don't think the ceiling is raised, that's for sure. because you really need to be very talented to be a very good AI engineer. But I think a lot more people are trying these things. Actually, another talk I gave recently, I was reading some research, like 99% of developers have tried putting or use LLMs in their daily lives, which of course includes coding, which is a bit biased. But I have seen a big pull towards this. And I think ultimately, to be honest, the reality is probably everybody at the workplace is going to be building agents eventually. I just think that's going to happen. So I think we're quite early. So there's an advantage also to be early to this market. Cool. Thank you.
Hello, everyone. I will start by introducing myself. Maybe I'll set up my screen first.
Yeah. I can stop sharing. Oh.
Okay. So.
I think you need to go back to the meeting and share the screen.
That's what I did. Hold on. Sharing the screen. Okay. Firstly, a big thank you to ZenML and Brevo for giving me this role to speak to you lovely people. I will introduce myself. I work at Louis Vuitton as an AI engineer as a part of the AI agentic revolution, as we all love to speak about. Before this, I used to work in consulting, and I have consulted previously for the French Army, Air France, and I did a full-time job at Vinci. For anybody who's French and has ever taken the autoroute, you know what it is. The idea today is for us to discuss human through AI. In the past few years in mass media, we all hear about human versus AI. It gives you the impression we live in Black Mirror. Whereas, let me tell you, if AI is in the right hand, it does not have to be dystopian. So we will be talking about how to empower ourselves by using AI and actually increase value and add business value into our workflows. So the first step will be to speak about agentic AI, the business vision, MVP, and strategy. The second is to design AI agents, which is followed by AI data governance, which I think is one of the key factors that stands today between actually building AI agentic workflows and deploying agentic workflows. The next issue is data bottleneck. I will be speaking about agentic monitoring in a way to discuss how to tackle this issue. Finally, it's question and feedback. So the ground will be yours. So I don't know if it's just me or everybody else has an impression that in the past 1 year, all we hear about is agentic AI. And I thought to myself, maybe it's a fever dream and it's only just me. So I went to look up some statistics from BCG. And they said that in the past 1 year, in the 4 quarters in 2024, 331% increase in AI agentic speak. So you can only imagine the mass value about how everyone wants to take a deep dive in agentic AI, which is followed by AI infrastructure, AI investment, and anybody who knows AI knows GPU is at the heart of the AI agentic applications. This brings me to the point that Hamza was building to us, and the idea is we need to realize the value that agentic AI is adding and how it's transforming us today in a digital transformation in terms of building scalable AI and transforming your existing infrastructure towards an infrastructure that will be able to deploy agentic AI. If anybody takes a random guess, in 2024, just 1% of the software in production was using AI. Whereas in 2028, it is expected to go up to 33%. So you only take into account the massive value and the increase that it's bringing into our lives. So the answer isn't about replacement, it's about strategic integration of machine learning workflows and agentic workflows. The example I like to give is I also give AI adoption and I work with change management at Louis Vuitton to give bi-weekly seminars to discuss about AI strategy. The example I take is a bit nerdy, so maybe this audience will be more receptive to it. I think of proactive agentic AI as Iron Man, Tony Stark. Like he said, if the plan does not work, don't change the goal, change the plan. And maybe reactive traditional AI is Captain America. And if we learn one thing from Civil War, it's that Avengers need to assemble and work together. So therefore, agentic AI, goal-orientated, autonomous decision-making, adaptive workflows, whereas traditional AI, task-specific, limited adaptability, and depends on human input. When we converge these two in a Venn diagram, it brings us to something which is quite useful. It allows us to do predictive reasoning, intelligent automation, flexibility, balanced prediction, and enhanced human collaboration. So the strategic integration today is between traditional consistency plus agentic adaptability. Once you find the sweet spot in the middle, I trust you, the business value will really shoot up. Why do agents matter? By 2027, 85% of executives forecast AI-driven automation will significantly facilitate touchless operations. Today, 81% of people say agentic AI is essential to them. These are figures by a report published by IBM. And when they speak about agentic AI, 90% people say it elevates their employee experience, and 75% people say it helps operational velocity. When we speak about how much value an agentic AI or any software adds in any company's value, when we speak at Louis Vuitton, we come up with KPIs. And the KPIs generally for us are adoption, accuracy, efficiency, because the idea is to go past the POC stage. Everybody loves to do the POC stage. You can do a very cute little front-end streamlet, but how do you get from that point to go into dev, to go to INT, to go into pre-production, and then go into production to the stage where you deploy agents? The agents that I'm deploying are being used by 25,000 people on a daily basis. So you really have to build something that is stable and that will actually add value. So you work closely with business teams. We work with data product managers, with the retail teams, with the finance teams. Everyone comes together to come actually find the sweet spot in how to move forward. So like Hamza discussed, there is multiple levels of how you can go through your agentic AI journey. The first step is just basic automation. What you do is you take one redundant task, you say, this is really boring, nobody wants to do this, let's fix one thing that will come through with this. That's a normal workflow. The second one is AI-enabled automation. What you do is you take workflows and you put that into place so that instead of tackling one issue, it tackles a broader perspective of the issues that come into place. The next step is where I think most of the companies are today, is interconnected and intelligent workflows. And the last step is agentic AI and autonomy. I was reading a research done by McKinsey to speak about AI maturity, and they said there is a scale of 1 to 4, with 4 being the highest maturity. And today, countries like China, America, and India, does anybody want to take a guess where they are? 2.7. So you only have to realize, like, before we actually make our way to agentic AI and autonomy, we have to reach level 4. And I think France is maybe halfway through. So the journey is quite big, and I think we have to work in a way that we build infrastructures that support such systems. Today, the biggest use cases that we have are customer service, human resources, and recruitment, because these require consistent tasks that need to be replicated over and over again, which is, in my opinion, quite boring. So I think it's interesting. Why does adoption matter? This is a very quick slide just to brush past the idea that change management is one of the biggest KPIs that we take into our consideration today at the agents that we develop at Louis Vuitton. If people do not know what AI is, they're not going to use what AI is. There is something quite interesting said by the CTO of Boomi, who said, people want to use AI, but if they don't know what it means, they will never use it. So I think it's quite interesting to take into account that in 2024, 33% of the workforce needed reskilling. Whereas if you look to 2026, it goes up to 56%. So you have to realize, if you do not bring your teams up to speed with AI and AI literacy, no matter how many AI softwares you're making and no matter how wonderful they are, if people don't understand what AI is, they will never use it. So this is the basic idea behind AI adoption. I came up with 5 points in which I think it could be good to optimize your AI strategy. Step number one, differentiate autonomy versus automation. You can choose something in the middle, but you really need to realize today, what is my use case? How can I actually tackle this? You go deeper instead of going wider. So you fix smaller issues and then you move past. So the second step is to evaluate use cases carefully. You start with strong foundations. We all are engineers, I can imagine. So we all studied in high school, garbage in, garbage out. That still stays today. If the quality of your data is tragic, your AI will be tragic. So you need to come with clear goals, quality of data, data persistence in how you manage your data, how you update your data. And then you come with a planned execution and lower risk operations. The fourth step, I think, is quite important. Like today, when you speak about AI at an enterprise that is the scale of a Fortune 500 company, AI governance and data security is pivotal, because today I am making a software. Why? Because I'm an engineer, have access to the whole of Louis Vuitton's application data. Let's say I have the sales data from the whole of the world of Louis Vuitton, which is like some 50 countries. But today, if I have a user who sits in China, who is an entry-level person, I cannot give them access to the key metrics that are only supposed to reach the CEOs in France. So how do I make sure that my application, which has access to all of the data, somehow understands when the person logs in to see, okay, this person is from China and is an HR entry-level job, so only this part of the data is supposed to be seen by this person, so that we are able to avoid data leaks and we're able to avoid very bad management of data. So that is very important. And the last one is upskilling your team, like we spoke about it. AI adoption really remains and matters at the heart of the very core operation of what is AI agentic revolution. Scaling AI is something which is quite important. We speak about it loads today, but most of the companies that do not actually make AI at scale, at what point do they get lost? It's when they forget about how much money it's going to cost them. So a lot of people invest time and money to make AI, but the moment that lies in making AI at scale is the hidden cost and complexity. We will see on a later slide that speaks about data governance and how it really makes a big difference. When we speak about designing AI agents, for me, 4 things are core principal values. The first one is agent design strategy. Do you, in your company, your enterprise, do you want to make agents that are, let's say, business specific per use case? Do you want to specify one for financial intelligence, one for retail intelligence? Do you want to mix them together and use A2A, which is agent-to-agent communication? Are you worried that's going to lead to data contamination? There's a lot of factors that come into play, and I think before you really start to talk about agents and even begin to build agents, you really need to clarify some core concepts before you can move on. System integration, we know today that we have A2A, agent-to-agent communication, and MCP, which is just a way to integrate tools within agents. So we need to discuss how we do this stuff. Data persistence strategy, how long do we want to store the data in cache? Today, I make an application, let's say ChatGPT. We all know that ChatGPT keeps all your data for the rest of your life. So if I work in a company today, let's say I am working on a chatbot within the Vuitton. I have somebody who is in China today. Tomorrow, they move to Japan. I need to make sure that what they had in China is not what they will have in Japan. So you need to constantly go through your permission matrix. You constantly need to update what you have, and you need to constantly keep on moving about and moving forward with this approach. The last one, my favorite, as you must have already understood, is governance and security framework. And this is also key in how to do risk management, compliance measures, access control, and data validation. This is a very simple design that I did just to show how agents would normally look like on an application such as GCP, which is our orchestrator that we mostly use. User is on the front. You do an SSO. You can use Okta. You can use Microsoft Entra ID. Doesn't matter. You go through the firewall. You get to the platform through which we generally recommend that you have a front and a back separate. You have the agent, which is the heart of the actual operation. You're connected to some form of database that's on the top, and the user logs that have been calculated. The user log is really it's not use case agnostic. Sometimes it is. We will go through that as well, how we collect logs and how to make that more useful in terms of your use case. This slide is just to very quickly go over A2A and FCP, which will be covered in the next talk, so I won't spend too much time going over in details what it is. But just to understand, agent to agent is when you have an army of agents who will be able to speak to each other. Let's say I am making an agent that can say, okay, I can ask a question. I can say, what is the status of order X and how long can I return it for? So how long can I return it for is store operation policies. And what is the status of this order is order intelligence. So in my head, I can say, okay, I want two agents, two isolated agents, one order intelligence, one store operation intelligence, and they will have to speak to each other at some point because he will say, okay, the status is it's in delivery, and then the return policy would be like, okay, the return policy is 30 days from the date that it's delivered. So they will talk to each other, make a new answer, and give it to you. But it depends. It really depends on the kind of application that you want to build and the sort of like strategy that you want to go for. 45% of the companies that are deploying AI agents today say that the reason they're not deploying AI is because they don't have a governance and security in place. You have to realize the bigger the company it is, the bigger the blue section it is for them. So it's a really, really complex process, and you do not want to go through with this and then have to scratch your head because you had a massive data leak or like it led to like big compliance issues. It's harder for agents because agents have a decision-making process. You need to do security compliance, audit trails, performance reliability before deployment as well. As I already mentioned, we generally go through 5 staging phases in which we have end-to-end testing on each phase. We calculate KPIs for each software that is going to go into production. You do first testing by you create a golden data set. You compare the answers that you get from your AI or the decision making from your AI to the golden data set. Then you do end-to-end user testing in pilot phases, which is like collecting feedback, doing workshops, and like speaking about how to move forward. So it all comes into play when you discuss building your application. This is just to show the access control use case. You have a user, an agent, and a database with data from all around the world. So you ask, how many days did Jenny from HR take this month? The agent will reply to you, she took 3 days off. And then you will try to say, can you please go and update this on Confluence? It's an internal software that we use. The agent will now realize, no, this is an entry-level person. She does not have right to go and update people's data on Confluence, like it's dead. So the agent will interpret the question. It will go through the security metrics that we have built with this, with the access control rights, and it will say that the user does not possess the rights that are needed to make this decision. So he needs to go and contact his manager, and only then they can move forward with this. Implementing access control, I took 2 examples that I thought were interesting, but then it depends on your use case. The first one is BigQuery data. BigQuery is structured data, so anything that is tabled is in BigQuery. Now the idea that I spoke about stocks and like order status and stuff like this, so I don't want people in Japan to see orders from Paris. You all agree. So what I can do is I can use policy tags, I can use authorized views, column level control, row level control to actually make sure that when different users log in, they have a different view for each person in terms of what they get to see when they ask the agent to like draw them a chart or a graph or like whatever. They need to actually ensure that they're not getting to see anything and everything, because that is a real security hazard. React agents as well, we build a security matrix. What we do is, once this is built, you store the access rights in the metadata with the vectorized data. So what you do is you vectorize the data in the metadata, the resource metadata, you store the information with the actual access rights that they have, and then you do this in the end. So data, biggest issue is bottleneck. We will be seeing how to fix the bottleneck issue with the next approach, that is monitoring your agents. Now, I would like to ask people how they think agentic AI monitoring is different from traditional AI monitoring.
Question is vague. What do you mean?
So today, I'll say that you have an application that's in production, right? What you generally do is that you put operational monitoring in place. So you will, let's say you will log the amount of responses, the amount of cloud runs that you're using, everything. So today, tomorrow, when you deploy agents, how will you actually fine tune your existing infrastructure that is logging your existing AI application to actually bridge the gap and move forward to agentic observability. You use what? Beef? Okay, I haven't heard of this. What does it do? Okay. Okay. But I will be introducing something called open telemetry. This is something that we use on a daily basis to actually do a vendor agnostic approach in terms of how you do monitoring. So you could be on Microsoft, you could be on GCP, you could be on your own platform service. It's vendor agnostic. The idea is you get a container on which you connect all the traces. You deploy this as a sidecar container, which makes it like scalable in terms of infrastructure. And then you plug this into any visualization tool you have, and you're able to like actually trace in real time the different logs that you get. But how it's different is that like agent monitoring requires visibility into decision paths, reasoning processes, and tool usage. That is not something that exists in traditional AI software. The non-deterministic nature of AI agents also makes observability a bit complicated because you have to really log everything to move forward. So this is the idea of doing agentic observability, enhanced performance, increased reliability, improved transparency, effective troubleshooting, and alignment with business objectives. Open telemetry, why do I think it's a good approach to use? Because let's take an example. I today say that I have a kid and I name him, let's say, Hamza, okay? And then you start to call my kid, let's say, John, okay? And tomorrow when you both go to like, let's say, Adam, and you say, yeah, I was speaking to Hamza, it was really great. They would be like, who's Hamza? He doesn't exist. So how are you going to make sure that people are speaking about the same guy? Is that you name the guy the same name. We agree. So the idea behind open telemetry is that they came with semantic naming conversations for different metrics that you use to track AI agents. Because it's a rapidly evolving new thing, currently semantic conventions don't exist. People name stuff however you know they want. There's different variations and different ways they measure it. I could measure something in liters. You could measure something in milliliters. Tomorrow we could have a fight about like who has more liquid. Like you don't know. So the idea is that you need to do what to measure, how to name them, and what format to use to actually like measure them. These are some semantic conventions that already exist. So like for agentic applications, you have GenAI operation name, agent description, then you have conversation, data source, output. Today, agent framework semantic conventions stay quite vendor-based because you have loads of frameworks. You have True AI, you have AutoGen, you have LangGraph, you have Llama Index. There's loads of them. So today we're building to get in a direction with open telemetry that we can tomorrow be able to compare my agent's performance with your agent's performance, regardless of what framework was used to build it. And these are some basic AI operations such as like token usage, operation duration, time to get the first token, and whatnot. The idea of an open telemetry pipeline is extremely simple. You have the telemetry collector, which is going to collect all the data. You have a container that is a side container. So you deploy that as a side container with your actual container application. You connect that to, in my case, GCP services. And then you just create dashboards and alerts. You can say, if the agent takes this reasoning loop 5 times, let me know. You know, it's a bad sign. You say, in the case that the agent takes this decision in like the first step that it does, it's a bad sign. I don't want this. Let me know. So this helps you to like constantly track in terms of like how you move forward. What is a telemetry container? It is just a vendor agnostic tool which is used to. Okay. So this is just the idea of how you do the vendors, the open telemetry stuff. And the last point is to visualize them. I use GCP, so we use Cloud Trace, Cloud Monitoring, and Cloud Logging. How this helps you, you do trace visualization. It helps you understand service dependencies, and also it helps you understand the root cause of your problem. Today, the biggest performance issues and bottleneck issues at AI agents are token processing delays, tool execution latency, memory constraints, and chain dependency. So for you to understand where do these problems come from, you need to log your stuff in a visual manner so you can see how it relates to each other, and then you can move forward to actually debug your problem. This brings me to the end of my presentation. I hope it was interesting. Questions?
Yeah, my question was about the access management.
Mhm.
Why instead of asking the agent to control the access, we create the copy of agents that different people of matrix of access have different access to different agents?
It's a good question. We did think about this, but then if you think in terms of scale, right? Let's say today in this room, we're 70 people. It's very easy for me to do this. I group you guys into groups. I say column 1, column 2, column 3. They get all the access. You get 5 things. You get 10 things. Problem solved. This is not an occupational hazard because there's a very small amount of people. Today we speak about ACL. We tried to do this a few weeks ago, and we found out there are 70,000 combinations in terms of like access control list that we have to the Louis Vuitton. So if I start to plan 70,000 different combinations, and it's permutation, so you have to realize that it grows exponentially. You can do it in some way if you have a small group of people. But today I'm speaking about worldwide deployment for my agents that is like in a few months. So I can either group people by region, by location, but even that's a bit specific in terms of how this moves forward. This is a good approach, but when you speak about scale, it's very hard to put this sort of stuff into place.
For agents, you add it in the metadata, so in fact you have the winners.
Exactly. But he's saying you create one agent per access control group.
So you have only one agent, and then we should define which metadata, which person has access.
Exactly. Exactly.
In the scale could be the way that you distribute the load also. As you have a copy of the agent and they manage different load.
I think it is a possible solution, but I think the more you add, the harder it is to maintain as well. So let's say today I have 70 regions. If I start to make 70 different agents, I need to hire 70 more people to actually come and do the work because the work multiplies. So we try to keep something central so that there is central control in terms of how we do stuff, because otherwise it's too much of an occupational hazard to go and track everything from every different corner in the world. And humans love to do, n'importe quoi. So like if it's 70 different groups, 70 different types of problems, I'll go crazy.
Good. Thank you.
Thank you.
Next up is Sam from Dust. Which is up. Oops. Sorry, Mahrukh. Yeah. Here we go.
Cool, thank you very much. Hello, everyone. I'm Stan. I'm going to be talking about unstoppable agentic loops, and we'll see what it means. Probably driving a little bit about what an agentic loop looks like, how it's looked like over the years from 2023 to 2024 to 2025, what problem it raised with the new agentic loops that we're seeing today in terms of production and how we can solve them. I'm the co-founder of Dust. So Dust is basically you were saying, if you see the vision of a network of agents operating autonomously through MCP, we're with you, and we're actually building it. We're really trying to build a platform that is an AI or an agent operating system for your company. You bring in the context of your company, you bring in the tools of your company, and then you unleash the Kraken on your employees, and giving them the ability to create agents, explore use cases internally, and try to accelerate their work. So basically, we have an interface. You see that we have plenty of custom agents, and you have a create button that everybody has access to, and everybody can create an agent very easily, adding tools, adding knowledge, and start messing with it. I've been lucky to work at OpenAI. So I started a company with Gabriel, another company with Gabriel, my co-founder, a long time ago. We got acquired by Stripe. Worked at Stripe for 5 years. Got to know Greg Brockman there. And at the end of Stripe, started interesting myself in AI again. And through Greg, knew Ilya, and eventually joined OpenAI kind of early. So I joined when there were 80 researchers and a slightly larger team around them. And I'm not a trained researcher myself, so I guess that makes me an engineer joining a researcher group. And so that probably makes me one of the patient zero of the plague that is turning every engineer into AI engineers today. And so There was a very interesting experience, and I did research on the mathematical reasoning capabilities of models. And by the end of 2022, I wanted to go back to product, and at that time we started working on Dust. And the goal of Dust is really to try to think and reinvent, trying to think and reinvent how work gets done in companies with agents. So we've been messing with models and agents for a long time now. And I'm going to try to cover really quickly what the agentic loops looked like over the years. So basically, kind of started in 2023 with the chat API from OpenAI. And so the very first version of the chat API OpenAI is really not an agentic loop. It's an API that takes user messages and returns with assistant messages. And you see the typing is pretty simple. The user message is basically a string, and the assistant message is basically a string. And you can't really mess too much with the order. We were already doing that at Dust because we had multiple agents. You could call them at the same time, but not all the APIs are like that. But that was kind of the basic API to agents at the time. Comes in 2024, and what appears is tool use. And so what means is that when you call to the model, whether it's OpenAI or Anthropic, you also have that tools parameter, which is a list of tools that the model can use. They have a name and descriptions and a JSON spec for the parameters. And so now the agentic loop looks like that. It's a user message, which is mostly typed as text. We see that the type of the inputs kind of changed. It went from just a string to a content array, so that it could put images as well. So it can be type text, or type image and some data. And then the assistants now can answer not only with a content type text, or maybe an image as well, if it's a model that can generate images. They can also answer with a tool use object, which is an array of name and parameters of the tools they can use. And so then in the agentic loop, you have a new role. So we used to have user assistants, and now we have a tool role, at least in the API, sorry. And so the tool role is really a response to the tool use request from the assistants. And in 2024, actually, the first guys to start interleaving syncing stuff inside of that agentic loop was Anthropic. I remember that when we moved to Claude 3.5, I think, when you would use tool use, they would start emitting syncing tokens out of nowhere. And like, what the fuck? What are those syncing tokens? It makes no sense. And so that was interesting because they were not kind of part of the API messages that you had to submit to the API back to continue the conversation, but there were events that were popping up there. So already gets a little bit more complex and comes in 2025. 2025 is the year of syncing. And so now you've got OpenAI with the response API and Anthropic with the interleave syncing data flag that they have these days can actually emit syncing stuff in between tool use. So now you've got a user submitting some content. The assistant will reply with maybe some syncing, maybe not, maybe some tool use, maybe not. The user replies with some tool results. So that's inspired by Anthropic. Anthropic basically removed the tool role and went for a user role that has content that can be tool results, which is interesting because if you're using Claude Code, that kind of explains how they can do interleave user messages during the agentic loop. So at the next tool use response, if you posted a message, they're going to be able to not only return the tool results, but also the user message that has been interleaved in syncing. Interleaved during the agentic loop. And so then the assistant keeps going on, do some syncing, re-emit some tool uses, the user re-emits some tool results, eventually the assistant some syncing, and finally the text. And so that's interesting because that API already with tool use, but even more with the syncing part, is pretty stateful, meaning that when you continue your agent loop, you really want to resubmit, you really have to resubmit all of that information that's been sent to you to continue the loop. In particular, the syncing as a checksum, and that's a pretty interesting one. Most of the, both OpenAI and Anthropic, they have that checksum logic. And basically the idea here is that it's probably, I guess it's probably for safety reasons. It's to make sure that you're not messing with the syncing that has been sent to you by interfering with it and sending back, because they kind of try to probably steer the models through the syncing steps. And so they don't want you to basically prompt the models through their syncing outputs. For OpenAI, the syncing is actually a summary anyway. And so the checksum is just an ID or an encrypted version of the full syncing. So that becomes to be a kind of a complex state to manage. But so let's say you have a product and you want to build an agent in your product, and so you want to add an agent loop in your product, and so you're going to have that something that looks like that. So an agent loop, you've got a user message, which is the first part of the state that we saw before. You kind of have to maintain that state because you know that at each step of the agent loop, you will have to resend that state more or less. And so until the agent is done, you get the agent response. So that's an asynchronous call to the API of OpenAI or Anthropic. You push in your state the agent response. In the agent response, there might be some syncing, there might be a full response, or there might be some tool use. And so you start executing the tools. So for all the tool use you find in the agent response, you push in your tool results the execution of the tool. So that's also an asynchronous method that can take time. And finally, if there were no tool use, you kind of, if there is some tool use, you push all those tool use in your state. And finally, if there is no tool use, that means that you probably got an answer and you just have to return the full state. And at this stage, you have the full state of the agentic loop for one user message and all the reasoning. And you can use that to reply to the user and say that was a response, and here's the full reasoning and all the tools that you executed. Obviously, it's a little bit more complex than that because you've got events to show progress of that agentic loop as you go. So all of those calls, I mean, this call here will generate a lot of events. If you're using MCP here as a layer inside of the execute tool, you're going to have some more events because MCP tools have notifications. And so you're also going to have to manage that. But that's a basic agent loop. And so you write that in your JavaScript code, your next server, whatnot, and you're very happy it works. But then you've got a bit of a problem because as those models are getting better, that actual loop here can take minutes. And more than minutes, if you think of deep research, it can take 30 minutes. And so the problem is that agentic loops are getting longer, right? Up to 30 minutes, let's say today. Yet your deploys are not getting more infrequent. And so this is a graph of a day at dust. This is the US here. This is Europe here. So we have still a lot of work to do. This is the shared time where they all sleep. And this is a graph of the errors. So you cannot read here, but it's called streaming chunk error. And so for anybody that uses Dust, I know there's one person here, it's a really infamous error in Dust. You're really pissed when you get it. It means that you're running your agent loop and for what the fuck reason it just stopped. And so, which is funny is that when you plot the streaming chunk error, so no, he's going to be happy because he understands what happens when you get this error. It's perfectly correlated to our deploys. So the change of color are the deploys that we're running throughout the day. So that day we run something like, I think I considered something like 12 or 14 deploys in the day. And you see that they are perfectly correlated with when we deploy. And so that means that for most of our loops today, we're still running them sync in the pod that initiated the agent loop. So when we deploy that pod, or when we evict that pod, we kill the loop, and that agent loop is dead. And so that's a problem that I think anybody implementing an agent loop in their product is going to have to face and is going to have to solve. And so the way we're working on that is through one solution among many others, but we actually looking into building it with Temporal. So now I have the crazy challenge of trying to explain you what Temporal does in less than a minute. And so Temporal is what they call a durable execution platform. What they have is that they have workflows, which are pieces of code that have no side effects. So in JavaScript terms, you cannot have an await inside of it. And then they have activities that can take side effects. And the workflow is only allowed to call into activities. But the workflow you can implement in code and you can put any logic you want. That workflow gets kind of transpiled into something crazy in Temporal, and they track the state of where you are in that code. And when you call an activity, it like schedule an activity on a queue, on a worker. And if the activity fails, it's going to let you retry it and maybe once, maybe twice, maybe forever. And so that's a really kind of nice platform because you can express the state machine of your workflow in arbitrary code. So it's very convenient. And yet the activity also expressed in arbitrary code, but you want to have your activity to be as much as possible indented so they can be retried. And so moving back to our agent loop, now you've got an agent loop split between a workflow, which is the no side effects state machine expressed in code, and activities side effect allowed. So you've got awaits of arbitrary functions. And here, as you can see, every awaits that you have are in front of the activity something. That's not real code. I made it up, and I'm sorry for the color coding. I did it manually. So basically, the agent loop as a workflow is you want to keep it extremely simple. It's like you've got a step. You're gonna call agent at step. We assume here that we have in DB the state of the conversation. And so as we do that activity, we'll be able to fetch the DB. And so if we have some tool calls, we're going to run activities for each of those tools. And once we are done, we break. Very simple. So the workflow remains extremely simple. It's extremely easy to understand, yet it orchestrates somewhat of a complex loop. And so then the call agent activity is the one where you're actually calling the model. And this one you want to have idempotence. And so what happens is that you're going to fetch state from your step. And so what you want is you want to go in your agent loop or conversation. You want to stop at that step. So imagine you add user message, some agent loop, user message, some agent loop, and you're at step 3. You really want to grab only up to step 2 in that loop, right? Because if step 3 already happened, but it failed midway, you don't want to have it. You just want step 2. And so you fetch your state, and the state is actually the state that we described in the slide before. You call your agents, so that's calling to those APIs, and then you get the agent's response. And then you want to upset those agent response. So the upset here is kind of important. You want to upset at step your agent response. So that means that you're going to be overriding whatever state you have there, because maybe you already retried that kind of a call agent activity. And then you reply with agent response filters, type to use, which means you respond with just the number of tools you're supposed to execute. So now we're back to the workflow. The workflow just receives an integer, which is pretty simple and nimble, which is nice because there's network between the two. And you go on and execute your tools at step and for the tool index Y. And so you're back into execute tools, and here you're going to fetch tool use from DB. So you're basically looking into the state that has been saved here to get your tool use. You execute your tool with MCP, and at the end, you really want to accept the tool results here. And so here it's interesting because this obviously executes with a type of tool code is pretty much not idempotent. And so you don't have a great solution here because that await fetch tool use from DB is just a read, that's fine. The tool result await execute tool is actually a tool use, so maybe it's going to be sending an email. And so sending an email by nature is not idempotent. Even the Gmail API doesn't have idempotency IDs for sending email. And so then what we're going to do is, as soon as you get your tool results, you want to upset that and store it in DB as fast as possible and return quickly. But really anything can fail here. So if it fails here, it's fine. Fails here, it's fine. Fails here, you can have screwed. Fails here, you can have screwed. And then you go back. And so that's a trade-off. It's a trade-off between having your agent loops that fails or having agent loops that in very few use cases might double write the execute tool, which is not great. But that makes us, and to conclude the talk, that makes us make a prediction. So we know that the execute tool here behind is LCP all the way down today, like every standardizing MCP. So you're calling MCP. And so that means that because of the requirement for having a durable execution agent loop, and because that execute tool here will have a very strong need if we try to predict a little bit the future for idempotency, probably means that inside of the MCP protocol, we're going to have idempotent ID support pretty soon. All right, that's all I had. Thank you very much. Happy to answer any of your questions.
I tried the same thing, but I have a problem. I tried to implement the future trait in ROS. Mm-hmm. How it's work is when you call asynchronous things, you do it. If it doesn't work, you let runtime to know when to recall it. So I put all the condition error to recall it again. So that's works, means if network error, whatever error, or my condition not met, to recall. But it became so slow, and I don't know why. That's the problem. And I don't use the loop syntax anymore. They just use the thing that I implement myself. But
it's in context of Temporal?
Yeah, I don't use the Temporal. I just implement manually the feature trait of ROS. Yep. And it's worked perfectly, means it's covered any error and keep working until, but became so slow. and I don't know why.
I don't know either. I guess, I mean, retries can obviously augment the latency, but at the same time, it's probably the case that I mean, at least our vision is that we're moving into a world where the agents are going to be more and more firing them and forgetting about them, or not forgetting, but going to do something else and come back. And so I think it's an interesting trade-off between obviously having a durable execution setup with some network between the two, transpilation of the code going to the whatever temporal master, etc. Adds some latency. It's not that much latency. I think firing up a workflow and having first activity is probably instead of instantaneous, it's probably a few hundred milliseconds or maybe less. But the fact that you accept retries and stuff like that will necessarily include a bit of latency. But the reality is that, as you were saying, the kind of a characteristic time of what an agent can do is really rapidly increasing. And so as a user, if the agent is good enough, you're really fine just letting it run, come back in 5 minutes. That's what like Cloud Code AV users do. Like when you're a crazy Cloud Code AV user, you check out your code base 8 times, and you boom, 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 4 times the same task on the first 4, 4 times another task on the last 4, and you go have coffee, and you're back, and you pick the best.
First of all, thanks a lot for the talk. It was super interesting. I was curious to know more about maybe real-time agents, because you talked a lot about, let's say, agents that you find and forget, and then they come back after Lord knows how long time. Do you have suggestions on how to develop, let's say, real-time agents, maybe also with Studio? And do you think, how far do you think are we from, let's say, having a kind of this effect that you displayed, like in a almost a real-time conversation? Thank you.
What do you mean by the effects that you discussed?
Like the efficacy level of similar agent that you have that take maybe hours to provide the results that are good enough, but like in not seconds, but like in 30 seconds, so why the agent is talking with you.
I mean, so the thing is that agents don't have exotic memory. That's the whole problem of that technology, is that so you have to bring back the context for each conversation that you have with them. And so there's really no path today without an unlock in terms of research towards an agent that can skip through just rebuilding context for a complex task and solving it. Again, using Cloud Code, use Cloud Code in the morning, you ask it to do something, it's going to be using like a Gaussian commands to search through your code base. It's going to be really good at that. It's going to take a long time, and it's going to find the information and provide a pretty good diff. You kill it and come back the next day and add something that is just right next to it. You shouldn't have to redo the entire work, right? And so that part is pretty incompressible because there is kind of a back and forth between the model and the tool. And so I think there's really no path to having a real-time answer to something that would take a month to somebody. But what's hidden here, which is interesting, is that you still have syncing token streaming, tool user stuff streaming, sub-agent being called streaming, all of that is being streamed. And so as you move towards something that is more of a durable execution platform, you also have to find a solution to kind of re-aggregate those events and make them available in real time to your users. That's something that you need to have anyway, even in the kind of classical in-sync loop in your product, because your loop is going to be running on one pod of your Qt cluster. But maybe that conversation needs to be read and followed by somebody else, and that person will connect. It's going to be connected to a different pod, and the agentic loop is running on pod A, but the other person is connected on pod B. So even there, you need to have a Redis in between to have a channel to distribute events and be able to find them from any pod.
Thank you.
What other solutions did you look into besides Temporal?
So we built over AV users of Temporal, and so really had no real reasons to look elsewhere. It's definitely not the perfect platform, but it's a really solid and good platform that we know very well. There is Gaussian solutions. ZenML is probably one. And in terms of a durable execution platform, there is also open source platform. I don't remember the names, but there is plenty. Implementing that with just a queue system like Kafka-like, probably challenge. Cool. I'm not taking more time between you and the drinks. Thank you very much, and I'll send you back.
It's relevant.
Yep.
Thank you. Thank you very much.
Thank you very much. That was really great. Cool. Two more organizational things. I would love to check you in with the QR code, what I said in the beginning. So first of all, I would send you the recording, and second, I would love to get to know you. If somebody needs to leave early or we don't get the chance to speak, please scan this QR code. Then we get in touch with you, or you directly reach out again. But that would be very helpful for us to, like, if you want to talk about your use cases or know more details, and we can even set up a call. So that would be really cool. Great. Then take some socks. Still, some are left. We don't want to take them back to Munich. And yeah, let's mingle. And most important is that you get to know each other, everyone, and we have fun tonight. So thank you, Brevo, for sponsoring.
Thank you.
Thank you so much.
Thank you. It was really interesting. Yeah.
Yes, perfect.
Yeah, thank you for all the talk. Was really interesting. Thank you. Thank you so much for the good
You had
questions.
so many questions.
Yeah.
That was amazing.
Really
Cool.
Thank you.
Yes, yes.
Okay, thank you.